So, good morning, Taiwan. Good morning. Okay, I'm going to talk about Rails. Rails kind of performance talk. So let's start off with a question. Have you heard that Rails is slow? Well, yes, it's everybody says so. And for example, I just found something like this on the internet last week or something. It's a website ranking like 36 web frameworks. Let us see, actually. Okay. So here's the website. I don't know who this guy is, but anyway. So this is the repository having 36 different web frameworks, benchmarking each of these, and ranking all these 36 framework by its speed, right? And here we have Ruby on Rails. So this is not just a rumor, it's a kind of real benchmark, right? So let's see if this is true or not true. So I don't want to believe someone's benchmark. So I want to do my benchmark myself, right? So let's compare something. Let's compare our framework with something else, which is known as a very fast framework. I mean, built on the fastest language in the world. Of course, I'm talking about Elixir, right? So let's start with this today. Let's take some benchmarks and see how slow Rails is. So here's what I did. Can you see the code? Okay. This was actually my first time playing with the framework, I mean, Phoenix. So I started with brew install Elixir and blah, blah, blah. I created a hello project and run something. I'm sorry if I'm doing it wrong. It worked for me anyway. And I created a action like this. It's actually here in this repo. I took the example from this repo, like Phoenix, Elixir. It's a very simple application, web controllers, like this. Just responding nothing. Nobody, no respond body, right? So here's something as simple as possible. I mean, responding nothing. And here's the result. It responded within like 100 microseconds. It's blazing fast, actually, even in the development mode. And the log, in my opinion, the log looks very cool. It has that unit, microsecond. Actually, Rails doesn't have that because I guess Rails doesn't need that unit. So anyway, it's Rails turn now. I created a Rails application like this and removed all these needless gems and run bundle install with under the vendor bundle path. So I want to monkey patch all these bundle gems later. Anyway, here's the action. It's not blank. It returns something. Hello, Taipei. So then I hit the web page via curl commands. Then we've got this result. It responds in 1 second. 1 millisecond. Right? It's actually not too bad. It's not that bad because it's kind of close, right? I mean, it's 1 millisecond is not very slow, right, for a human. So, but I wanted to see more accurate number, so I wrote dispatch. Again, I bundled all these gems under the application so that I can do something like this easier. So here's my first patch. Just add some zeros like this. And here's the result we got. 600 something microsecond, right? So this is the fact. Production mode Rails application is 5 times slower than development mode Phoenix application. Yay. It's 5x Ruby. Yay. So anyway, Phoenix is very fast. So fast. It's great work. Jose is really doing great work. So how can you make Rails as fast as Phoenix? This is the topic of my talk today. I'd like to make Rails as fast as Phoenix, and I'm actually not going to introduce some kind of like magical gem that makes Rails 5 times faster or something. But I'd like to share some like ways to tackle this performance problem, and I want to show you some like approaches that I know. So I want you all to join this like journey and think together with me, right? Okay. So let's find out which part of Rails actually takes time. Measure. Firstly, measure. So we can think of several approaches to measure, like just measure it elapsed time, or number of method calls, or number of object allocations, or memory usage. Firstly, measuring elapsed time. This is, you can do this by benchmark module. It's pretty common, right? I guess you know this already, so I'm not going to explain here. Okay, next up is object allocations. So, you know, Rails allocates so many objects during each request. So, yes, I'd like to measure how exactly, how much. To measure the number of object allocations, you can use object space. It's a standard library. I mean, it's bundled in Ruby, so you don't need any gem or something. Just hit this method, object space count objects, like this. So in this example, I made a very simple rack middleware and mounted the middleware. So it counts the objects before calling the like mounted middleware, and after calling, then just subtracts each number of objects, right? And I disabled the garbage collection so that the GC doesn't not to collect the objects. And here we've got the result from the previous application that I showed you. So the Hello Type A application allocates like 200 arrays and 159 strings and 71 hashes and these objects. It's pretty much a lot of objects, right? So I handmade this tool, but actually there are already crafted gem for doing this in more like smart way. It's called Allocation Tracer, created by Koichi. So all we actually need to do is just bundle this gem and rewrite the middleware like this. Now the object space has the Allocation Tracer module, and you can just trace what the object space does, right? So the result looks like this. It's pretty much similar to what we had in the previous my middleware, right? Again, it allocates like 200 arrays and 100 and something strings. So where in the application do these allocations happen? Let's dig in these allocations deeper. So actually, Allocation Tracer can show some more details like this by adding the path option. So it now reports the exact place in the Ruby code, like this. Here's the result. So in logger.rb, it allocates 25 strings, and in http response.rb, it allocates 25 strings, arrays, and blah, 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 like that. So where should we start? In the middle, we see tagged logging.rb that allocates 15 arrays and 15 strings. So I think it's a good start point today. So here's the code. Here's the code that allocates 10 strings and 10 arrays in the Hello Type A application. It's inside tagged logger module. I guess you know what it does. It adds a tag before, it prepends a tag for each, a unique tag for each requests log. So basically each request has one tag basically, unless you specially configure it. So it almost always has one tag, and if the tags count is 1, it creates an array and creates a string for each this tags collection. So anyway, here's the patch. This can be very easily improved by like counting if tag is 1, then don't create array, right? So here's the patch, and I committed this to Rails yesterday. So I guess Rails 6 is getting a little bit faster. So then I took the benchmark again. Now the tagged logger doesn't appear in the list. So next up is hash with indifferent access.rb. I'd like to look at that object. You know what it is? It's a it's a kind of hash that can handle both string and symbol as its key. So, it creates very, very too many objects because basically each time you use hash within different axes, you stringify all these keys basically inside the object. So it creates so many string objects, right? And in old versions of Rails, we needed this because without this, Rails is going to cause a symbol fixation kind of security problem. But recent Rubies will run garbage collections against dynamic symbols. So we actually do not need this module anymore, right? So maybe we can just remove this object totally from Rails and write every symbol literals with symbol. I mean hash literals with symbol. Okay. So this is my first step. Again, I created a middleware, like converting all env hash to a symbol-based one. And so here's the result. We got this error. Of course we got this error because Rails assumed all hashes to be string-based. So we need to rewrite everything in Rails to accept symbol-based env and request and response and cookie and session and everything. So I actually did this yesterday. Like I needed to patch like about 100 files in Action Pack and Action View, Action Support, Rack, WebRick, URL, Sprockets Rails, and so many other like modules. And finally, I made it. I could make it kind of work. It's not still perfect, but it kind of returns some kind of result now on my local machine. So here's the result. You see, we previously had this much objects. So now it reduces just a little bit, like 10% or something, right? So I proved that we can reduce some object allocations by removing hash within in different axes. Here's the actual patch. So I replaced all like string keys to hash, like this, like this, like this. And in Rails land, in the Rails side, we needed to do something like this. And in some cases, I removed this method call so that, the parameters don't have to be the hash within different access object anymore. So, or like this, like this, like this. Also, I patched the Mhm. Oh, here. And I remove some stringify keys method. And I changed the hash with indifferent access class to be symbol based. So hash with indifferent access has another hash inside with string key. So I rewrote this object to be symbol key based like this by rewriting convert key method. So this is what I did. So here's the benchmark we've got. Actually, not a very big improvement, but seems like 10% or something improvement. I told you that this patch is not yet done, so I guess I need more work on like action view or something. So anyway, here's the result as of today. So again, this is the result that we have now. And you may notice that most of the time is spent in view, actually, right? So what exactly the view means and what the view does while we're like rendering simple hello Taiwan, inline hello Taiwan. So we're not even rendering a template. Why is it so slow? Right? So here's something from action controller. So here's the code that shows the log, views colon log. So the actual number of the views speed is taken from payload view runtime. So what is view runtime? Here's what sets the view runtime variable. So it is exactly the time spent for render method, right? Inside render, it calls the benchmark and calls super. So view runtime is just a time elapsed for render method, okay? We actually can just make sure by adding something like this in our controller, and like you see, these are almost like same, right? So why does it take that much time? Okay, so when we call render method explicitly, something like this, if we do not call render, this method is called inside the framework, default render. And default render finds a template from the controller class name and the action name, and then renders it. So basically, default render is something like template lookup plus render, okay? So anyway, here's our actual code, render plain. So how can we like trace what's happening here? I used trace point for this, like this. So with this trace point, I trace all Ruby level method calls and output that to standard output, and the result goes like this. I'm sure you cannot see the result. So this just counts the number of method calls. I mean, list up all the method called, and it turned out that render plane calls 244 methods. This is too much for just showing hello Taipei, right? So here's your homework. I'm not gonna dig into this in this session, but I showed you how to like list up these methods. So if you're interested in this, please do this and like dig into the framework. So now I'm going to show you another way to dig more detail for you. So I'm going to introduce another useful gem called Memory Profiler. It's created by Sam Saffron. And this gem shows not only the like file names and file lines, it shows something more in details. So here's an example result from, again, our Hello Taipei application. At the very top, it shows the total memory usage. And what else do we see? Allocated memory by location. Allocated, yes. Each actual string objects and each of its allocated lines, right? So now let's try a little bit more like real world-ish application. Like this. It's so real. Now we use a template instead of render plane. And here's the result. This was the previous result, like 36,000 bytes, and with one template, it doubles the memory usage. And in the memory profiler log, we see something like this. It's very interesting. You know, in the template we have something like this from the layout, application layout. So it renders application style sheet tag, and for rendering that one tag, it creates 3 tag strings and 5 like file names strings, right? So that's how we use that much memory. So how does ActionView duplicate these strings like 5 times or 3 times? So it's broken, sorry. Action underline view tag. Let's take a look at this file, tag helper. It's there in the log. So this is how you can chase the performance problem. It's in the memory profiler log, so just open up that file. Then you'll see some clue in the file, right? So I decided to take a look at the action view helpers, tag helper, line number 93 as an example. So here's the code. The 93rd row is the bottom one. Can you see why this code duplicates the strings? What's wrong with this line? The answer is that string G sub duplicates the string. So you may need to use G sub exclamation instead, like this. So here's the patch. At the very bottom, I changed the G sub to G sub exclamation. And here's the patch I committed yesterday. And result improves a little bit like this. It was like 68 or 69,000 or something. So I could reduce the memory usage like 1,000 bytes or something. And another string duplication occurs here inside style sheet link tag. Again, according to the memory profiler output. So what's happening here is, first you create a tag string in this. So this line creates the tag string, and this code wraps the created tag and calls join. So it firstly wraps in an array, then calls join to the array. So the join returns a HTML unsafe string. Then, so you need to call .html safe there. So this process creates 3 same string objects, even if we have 1 tag. So sources here is the given parameter to the style sheet link tag. And remember, I guess you remember, most of the time we give just 1 parameter to this style sheet link tag. In this case, application. So we only have 1 tag, but still this creates 1 array with 1 tag, then creates an array, then converts the string back to non-HTML safe 1, then converting the string to HTML safe 1. So that's what's happening here, right? So I made a patch again, but this time I couldn't see no big performance improvements. Because in this case, it's just one single helper method. So there's no like 100 calls to this method or something. So maybe this is not a big deal, even if it duplicates the string 3 times. Anyway, this is the patch I wrote. And I don't know, I haven't committed this yet to the upstream, because I couldn't see any significant performance change with this patch. So another thing that I'm interested in is active support, output safety.rb. Excuse me, let me get back to the list. Yes, it's there and there, output safety. So this object duplicates this string object so many times in the log. I mean, this appears so many times actually. And if you open the exact line in the log, you'll see it duplicates the strings when creating the instance, or like calling this method, Unicode TD bytes or something. So what the TD bytes method does is it kind of cleans up the string to be Unicode safe string. I'm not going to explain in detail, so please consult the code yourself. I guess we can improve this if we drop Rubinia support. Or maybe we can like create something new, newly designed safe buffer that does not duplicate strings. I guess it's possible, but nobody has done yet. It's a long time to do for the Rails team, like since 7 years ago or something. So I guess I have 20 more minutes. Okay. But I have no more slides. So, there. Okay. So here's the hello application. Let me quickly show you the history again. I just created the application. And bundled hello type app action, a millisecond patch, I'm sorry, microsecond patch, and what's this? Object space, count objects, GC disable, bundling allocation tracer jam, using allocation tracer middleware, showing path now, the first Rails patch, symbolizing the env, symbolizing hash within different access, and removing within different access calls, removing stringify keys, rewriting everything in Rails, and in rack. Then sub for nil class. It's not working. Come on. Okay, it works. So we're having this result. You know, there are so many hints for another hack, right? You see here it says we've got 30 strings in logger.rb. I don't know why. Or like HTTP response create 25 arrays, or like inflector. It does something like it's converting hello to hellos or hellos to hello. I don't know why it creates 15 strings. So there are so many hints in this list, right? Not here. どこだろう? Maybe on the stash? わかんないな。10 minutes. どうしよう。If I have more time, ooh, what's this? I wanted to show you some actual live coding, like dealing with database and making it faster or something. Let's do this in 5 minutes or so. Oh, なんだこれ。2画面難しいな。どうしようかな。Rails generate scaffold user name email. いや、これでいい。Migrate git add. Rails. DB might. It's 5.2. What's wrong here? DB 見えない。合ってない？合ってる。そうです。I did not bundle active record with this application, so that's why. Okay, so I guess it's time. So again, here are homeworks for you. Anyway, so I hope you got some good ideas for your weekend or Golden Week hacks, right? And I hope you got some like actual tools in your hand now. So as I showed you, there are so many problems and so many rooms for improvement in Rails. So yes, there are problems, and we need to improve this situation. Okay. So as Koichi and Kokubun-san talk to you in their talks, Ruby is getting faster and faster because of their hard work, but Rails is, I don't know, not getting faster like Ruby. I mean, yeah. So I'd like to encourage you to tackle these problems. There are so many problems. There are so many things that you can do. So please, 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 please improve these problems. I mean, I'd like to do my work, but I like you also to try finding problems and try solving these problems. Okay? Thank you. Thank you very much.
Thank you for Akira-san's sharing. Do we have any questions from the audience? Once again, please.
Oh, hi. Thanks. So I checked out Rails master, the commit. Did you commit directly to master
Yes,
yesterday?
I did.
No need pull request for that.
No, it's just that. So these are just small changes. I don't know. As a Rails committer, I don't have to make a pull request for it. So such small issues and obvious improvements. Actually, okay.
One commit failed the test, right?
Right. That's a very good question. So I directly committed my changes, and I broke the build like this. Yeah, I broke the master yesterday. I'm sorry. And then, because of the RubyConf thing. I don't know. The style matters to some people. But actually, it didn't change anything. So this was my commit. I just like extracted the string from here to here. Then RubyConf told me that I was wrong. Anyway, thank you.
Do we have any more questions from the audience?
Hey, whenever you do some performance improvement, you kind of reduce the readability of the code. Like the example with an array with one element of the tag, obviously the code is more readable if you don't have this exception for the one element.
Right.
So how do you decide when it is worth to improve the performance at the cost of the readability? Do you have some rules?
Right. Thank you for a great question. So basically, don't do these ugly hacks in your application code. In most cases, you don't need to like write fast code for your applications. So yeah, this talk is about the framework or library where, you know, like for example, five minutes, okay. For example, in this example, the tag option method is called for each tag in action view for each attribute. So if you have like 10 tags in your for example, form 4, field 4, text field, then and it has like name or like I don't know. There's so many like attributes on it, then this method will probably call like hundreds of times per each request. So in such case, it's worth doing this dirty hack. So my answer is depends.
Okay, let's have one last question from the audience. Excuse me, can you use the intercom?
Does that work? Yeah.
Yep.
Yeah, looking at those memory allocations and then hunting them down one by one, is that maybe if you take a step back, is looking at 100 allocations doesn't seem a lot if you compare it to like other environments. So for example, if you compare that to the Phoenix allocations that happen as well, do you think that this is more an underlying issue within Ruby, that allocations should be faster, or is really the right approach to try to go through the framework and remove all of them? It seems like a very tedious task to do.
I don't know. This can be one approach that I and you can do, and maybe Koichi will take another like more clever approach against the underlying performance issue in Ruby side. I don't know. I just wanted to show you what we can do. Does this answer your question?
Thank you. Okay, do you have any questions, or do you want anything you want to add up to your presentation? No?
Okay.
Okay, well, thank you very much for sharing. Okay, let's give a round of applause for our speaker.
Thank you.